All right, guys, we're going to jump right into graphing tangent. I think the easiest way to draw graphs you're not quite sure of, just like we did with sine and cosine, is to make a table of values. Again, we won't do this every time, but a good way to get started. So I know you all, if you had the time, could find me tangent of 0, 45, 135, and so on. But I'm just going to give it to you now so we can speed up and get to the important stuff. So tangent of 0, 0, 30 is root 3 over 3, 45 is 1, 90 is undefined, 135, we've got negative 1, 150, we've got negative root 3 over 3, 180, we've got 0 again, then we've got positive root 3 over 3, then we've got positive 1, then we're at undefined again, then we're at 315, which gives me negative 1, negative root 3 over 3, and then 0, okay? So let's first start by tackling, now we have a series of values, how we can graph these values. Let's start with the undefined ones. The undefined, since we're getting, if you remember, tangent, right? Tangent is sine over cosine, sine of x over cosine of x. We're getting undefined when we divide by 0. And if you remember, when we divide by 0, we get a vertical asymptote. So we're going to have a vertical asymptote at 90 degrees. So basically a line here that says there can be no point that exists at 90 degrees. There can be no point that also exists at 270. So we draw a line that looks like that, x equals 270. And if I work my way back to the left, it would also be undefined at negative 90. Okay, at negative 90, cosine would be 0. So we could keep on going. This graph would go on forever. But we would have asymptotes every 180 degrees. Okay, let's start with the 0 points. I know at 0, 0, I'm just going to switch colors so it's be very clear. At 0, 0, I know I have a point. Okay, that point there is 0, 0. I know at 180 degrees, okay, I have a 0. Now notice those 0 points are halfway in between the asymptotes. Right, halfway between negative 90 and positive 90 is 0. Halfway between 90 and 270 is 180. That's a key feature of the tangent graph. It's those points that are crossing through. In reality, we have a midline here as well that are crossing through this midline at y equals 0. Those midline points are halfway in between the asymptotes. Key feature to remember. Okay, key feature to remember. So I'll say, I'm just going to call them the 0 points. 0 points, halfway. Okay, they're halfway between the asymptotes. All right, so if we continue graphing this, 45 degrees, comma 1, that would put me right there. And conversely, negative 45, negative 1 would also put me somewhere around there. So that's 45, comma 1. This is negative 45, negative 1. Let's do 225, positive 1. That's 225, positive 1. And then this one is 135, negative 1. Got 135, negative 1. Okay. So now, if I think about graphing, so let's start with the piece in between negative 90 and 90. So what we have going on here, and we could find it by the values, is I have a graph that's going like this. I got to hit that point 45, 1. Now what's this graph going to do from there? It can't hit the asymptote, so the graph either has to go up or it has to go down. The graph cannot go down because it would be creating a new asymptote. Now what I mean by that is, right, imagine I hit 45 and then that graph in green went down. I'd be creating a new asymptote there if the graph had to go down. Excuse me, a new intercept, which you cannot do. You cannot create a new x-intercept. So the only place that that graph can go, erasing this green part, is up. Okay, and conversely, if you found tangent, take your calculator out, do tangent of 89 degrees, you'll find it's a really big number. Okay, and conversely, for the same reason on the opposite side, my graph must hit negative 45, negative 1, it can't go back up and create a new x-intercept, and it cannot run into that dotted line, so it's forced to go down in that direction. We kind of get this little snake-like feature. Well, if you look at the next kind of silo there, looks like the points are taking the exact same shape that we just saw, and indeed, that is the case. We will get another graph that looks kind of like that, kind of wavy in between, and then flattens out or gets steep, and we get this series of graphs, little mini graphs over and over and over again. So if I were to keep on graphing these asymptotes, I would keep getting these same shapes. So notice it repeats how many degrees? Every 180 degrees, we get a repeat of this snake-like feature. So keep that in mind as we dive into the next thing here, comparing cosine, sine, and tangent. So let's think about cosine, sine, and tangent. The period of cosine and sine, provided we didn't transform it in any way, was 360 degrees, because that's how long it took to repeat. However, looking at this tangent graph, how long did it take to repeat? Looks like it repeated every 180 degrees. So there's a key difference between the cosine, sine, and tangent graphs, is that they repeat, okay, at a different interval. Tangent 180, cosine 360. Maxes and mins, your max and mins for cosine and sine were both 1 and negative 1. However, notice these arrows are pointing up, meaning they go on forever in both directions. That means, guys, that my max is really infinity and negative infinity. Technically, they aren't maxes and mins, but I just want to drive home the point that it goes on forever in one direction up and one direction down. Technically, it doesn't have a max or min, but for right now, we'll call it that. The domain for cosine and sine, negative infinity to infinity, and the range is negative 1 to 1. Domain for tangent is negative infinity to infinity, except, I'm just kind of writing it in this weird way. I'm not too concerned about technical notation here. It's negative infinity to infinity, except, we'll just say, I'll say all asymptotes. Okay? So all the asymptotes are not included in the domain. So in the graph I drew, negative 90, 90, 270, what's the next one? 450. Those would all be excluded from the domain. And then the range is negative infinity to infinity. Okay, there are no y values that are excluded. It has every y value imaginable. Thus, the range is negative infinity to infinity. The roots, let's just skip the roots for now. Asymptotes, cosine and sine, have none. But for tangent, negative 90, 90, 270, etc. Remember, those go on forever. Okay, they go on forever. All right, guys, let's jump right into graphing these, okay? So graph the function tangent of x over 2. All right, this is something we can do. Amplitude, we're going to treat it the same way we treated cosine and sine, by the number in front. There's an invisible 1, so the amplitude's just 1, and I'll show you how we do that in a second. The period, instead of doing 360 over b, we're going to do 180 over b, because 180 is the normal period, so 180 over 1/2 equals 360. So that's the period. So that's how far apart the asymptotes will be. The half period is how far from your asymptotes your zero, quote, 0 points are going to be. So it's helpful to know that the half period is 180. The midline hasn't been shifted up or down, is 0, and your asymptotes are x over 2. Instead of setting it equal to 0, I want to know what happens to my asymptotes. Normally, I would have an asymptote at 90, so I will take what's on the inside and set it equal to 90, and that will tell me where my first asymptote is. Thus, my first asymptote, or one asymptote, is 180 degrees, and it's not flipped. Okay? So here's how we graph this. So I'm going to start by graphing the asymptote first. So I'm going to graph 180 degrees. So there's one asymptote. But for these, you need to graph 3 asymptotes. I need 3 asymptotes. I want 2 periods. So you might say, how do I find the other asymptotes? Remember, the asymptotes are always a period away from all other asymptotes. So we have one asymptote. If we want to find another one, we just have to go 360 degrees in either direction of 180. So if I go 360 degrees to the left, that's going to take me to negative 180. And if I go 360 degrees to the right, That's going to take me to 540. So there are my asymptotes, and I'm also going to make sure I graph my midline, which is always going to be 0 unless we switch it, and that's where my 0 points will be located. So let's remember my 0 points are always halfway in between the asymptotes. So halfway between negative 180 and positive 180 is 0. So I've got 0, 0. Halfway between 180 and 540 is 360. So I have the point 360, comma 0. I know the graph's going to take this snake-like shape. Right? It's going to take that snake-like shape. We need 2 points on each mini graph. So what we need to do is graph an additional point. Now, if you notice on the last graph, the points that had y coordinates of 1 or that were 1 above were always halfway between the 0 points and the asymptote. So another halfway thing. So notice here, let's come back up here, this point here, 45, comma 1, the point that was, I should say, rather than 1 up from the midline, the amplitude up from the midline was halfway between the 0 point of 0, 0 and the asymptote of 90. So notice that point, again to repeat, that is the amplitude above the midline, is halfway between the 0 point and the asymptote. So to find the point that's the amplitude above the midline here, I'm going to go halfway between 180 and 0, which would take me to 90. So this point here would be 90, comma 1. Well, same thing over here. What's halfway between 360 and 540? That's 450. 50, comma 1. If the amplitude were 3, then those points would be 90, comma 3 and 450, comma 3. But it's not, it's 1, so we're only going to go the amplitude up. Okay? So in each little mini graph, you need to have 2 points. The easiest points by far to plot are the 0 points, okay, and the the amplitude points. Okay? All right, here's what I would suggest for number 2. Give it a shot on your own. Hit pause, give it a shot on your own, and then once you think you have the graph, unpause it and see if you match my answers. Okay, hopefully you got a graph here. I'm going to run through this fairly quickly. Amplitude is 2. Period, I'm going to do 180 over 1/2. Ooh, 360. So same period as last time. Half period is going to be 180, half of 360. Midline is still 0, hasn't been shifted. And to figure out where my asymptote that's normally at 90 goes, I'm going to set x plus 90 equal to 90. X over 2 plus 90 equal to 90, sorry. And if we solve that, we get x equals 0. And is it flipped? No. So that means I have an asymptote at 0 here. Let me do that. I'll do this one in blue this time. X equals 0. To find my other asymptotes, I know they're going to be a period to the left and a period to the right. So if it's at 0, that makes it really easy. That means I have a vertical asymptote at 360, and I have another asymptote at negative 360. Let me plot the midline. Y equals 0. I know my midline points are going to be halfway in between, so I'm going to have 1 point here at 180, comma 0, and 1 point here at negative 180, comma 0. I know my graph's going to take that snake-like shape, just like that. And to find my amplitude points, okay, my amplitude's 1, so, excuse me, my amplitude's 2. Excuse me, I know my y-coordinates then will have a y-coordinate of 2 since the midline's at 0. And it's going to be halfway in between, so halfway between negative 180 and 0 is negative 90. That point there is negative 90, comma 2. This point here would be 270, comma 2. Hopefully you got that. If not, make a note on your paper what you got wrong, and make sure to ask me if you're still unsure next class. All right, that's tangent. Okay, so for homework, you're going to do number 3. Okay, I want to jump into cotangent now. Cotangent we'll do very quickly because we should be able to do it quickly now that we know what tangent looks like. All right, so cotangent. Amplitude's going to be 1. Period. Cotangent, again, don't forget it's just the reciprocal of tangent. So there's no reason why the period would be any different. Period's going to be 180, which means my half period's 90. Has not been shifted up. Y equals 0. All right, if you think about this, remember my asymptotes were where tangent was undefined before, right? So if you think back to your unit circle, where would cotangent be undefined? And if you remember, cotangent was undefined at 0, which means I'm going to have an asymptote at 0, x equals 0, and is it flipped? No. Okay, so I'm going to have a vertical asymptote at 0. I'm going to go a period to my right, which is 180. I'm going to go a period to my left, which is negative 180. I'm going to have the same things. I'm going to have those midline points halfway in between. So halfway in between is 90 comma 0 and negative 90 comma 0. Okay, so notice though, now that my asymptotes are shifted, the graph's going to look a little bit different, and here's why. So let's take 45 degrees. What is cotangent of 45 degrees? Cotangent of 45 degrees is 1, meaning if I plot the point 45 comma 1, that's going to be up here. Interesting. If I try to point cotangent of 135, I get negative 1, which means the point 135, negative 1 is going to be on my graph. So what's happening here. Instead of rising, my cotangent graph is falling. Okay, falling. And you're going to have the same thing over here, a falling graph. So what's some of the differences between the cotangent and tangent graphs? One is the cotangent graph is falling as you work your way left to right, where tangent is rising. And also the asymptotes are at different places. So there's a lot of commonality, right? A lot of those halfway points and 0 points, a lot of those rules of like halfway in betweens work. But just notice the asymptotes, okay, are at different places, as are these 0 points. But relative to everything else, they all match the same, okay? And it's also falling. All right, I want to do one cotangent graph together, and then we're going to call it quits. I don't want this video to get too long. So let's do cotangent together. If you're feeling really confident, you could do it yourself. If not, you want to do it with me, that's fine too. All right, so we've got amplitude of 3. We've got period of 180 over 1, which is 180, which means the half period's 90. Midline, finally we have something other than 0, is at negative 1. The asymptote normally is at 0, so we say x plus 45 is equal to 0, which means x is equal to negative 45. And is it flipped? No. All right, so let's plot some things that I know. I know the midline's at negative 1. So let's create the midline at y equals negative 1. Make sure to label everything. I know I have an asymptote at negative 45. Vertical asymptote at negative 45. And I know to find my next ones, I have to count a period away. I don't want to go too far negative, so I'm just going to go to the right. So add 180 to negative 45. That gets me to 135. And then if I keep on going another period, that's going to take me to 315. So those are my 3 asymptotes. If you went in the negative direction and got x equals negative 225, that's fine too. You could have a vertical asymptote there. All right, I know my points. Let's do a little Christmas theme here. My 0 points are going to be halfway in between. Okay, so this one would be what? 45 comma negative 1. Again, I'm just taking the average of negative 45 and 135. And then the average of 135 and 315, that will get you the halfway point too, is 225. Sorry, not positive 1, negative 1. 225 comma negative 1. And again, I know my graph is going to fall as you work your way left to right. Now you can find the amplitude points that lie above the midline, or you could find the ones that lie below. Let's find the ones that lie below this time. I'm going to go the amplitude down, which is 3. So that means this point would be halfway between 45 and 135, which is 90. And go the amplitude down, which is negative 4. So same thing over here. What's halfway between 225 and 315 is 270. And what's 3 down? Same thing, negative 4. All right, so there's your graph of cotangent. Make sure you graph 2 periods of each, and you need 3 asymptotes to do that. Your homework on the cotangent portion is number 3 here. So you have 2 graphs to do for homework, okay? The one cotangent graph and that one tangent graph. Notice that tangent graph number 3, we have a negative. Think about what that means in terms of the graph, okay? Make sure you note any questions, and we'll talk about them next class.